Good afternoon, students. In today's class, we are going to discuss about current components of transistor, and later on we will see the configurations of transistor. Let it be that is first configuration is common base configuration, common emitter configuration, and common collector configuration. Like that, we are going to see one configuration after the another configuration. First, we will see the what are the different configurations of transistor. Okay. Please tell me whether my screen is visible or not. Is it visible? Is it visible, students? Anyone please respond? Anyone please respond? This is BJT, bipolar junction transistor. Then it is of two types, that is PNP and NPN type of transistor. This is the symbolic notation of transistor. Arrow mark outwards means that is NPN transistor. Arrow mark inwards means that is PNP type of transistor. This arrow mark indicates conventional current flow. Conventional current flow. That conventional current flow is opposite of electron flow. It is inbuiltly consists of two diodes are present in transistor. That is, those two diodes are N to N cathodes are connected. That means I can take that terminal as N-type semiconductor, and in between P-type semiconductor, and in the extreme end, and that is N-type semiconductor. Altogether, we can call this as NPN type of transistor. Similarly, both the anode terminals are connected at the extreme ends, and between cathode terminals are connected. Then I can draw the terminals as emitter, base, and collector. I can call the transistor is a PNP type of transistor. Okay. And later on, what is the function of emitter means which emits the electrons or injects the electrons into the base, and those electrons are transmitted to collector. Like that, base means which bypasses those electrons and it is transmitted to the collector. Collector which accepts the electrons or collects the electrons from the other terminal, that is from emitter side via base terminal. And this emitter terminal or the emitter region is heavily doped, but it is the width of this region is moderate. Base region is lightly doped, and the width of this region is very thin, whereas collector terminal, it is moderately doped, but the width of this region is high. But the width of this region is very high, because that is the dissipation of heat is very high across this collector only. Okay, the basic difference between, in order to identify any transistor, the basic difference between PNP and NPN transistor is arrowhead upon the emitter. Arrowhead upon the emitter. That arrowhead is outwards means the transistor is a NPN type of transistor. NPN type of transistor. If the arrowhead is outwards, this arrowhead is outwards, I can call this transistor is a NPN type of transistor. If the arrowhead is inwards, I can call the transistor is a PNP type of transistor. Okay. And later on, this is the laid diagram for PNP type or NPN type of transistor. This is NPN type we have provided here. That is emitter terminal, base terminal, and collector terminal. This emitter and the base terminals. This emitter and the base terminals will gives rise to some depletion region across these two these two layers. One depletion region is get created or junction is get created. I can treat that junction as emitter junction here. The depletion region at emitter junction JE. Similarly, here also another depletion region is get created due to this P-type and N-type semiconductor material. The depletion region across at collector side, I can treat that it as JC here. This depletion region, normally emitter junction, normally it should be operated in forward bias condition, whereas collector junction, it is normally operated across in the reverse bias condition. ఫార్వర్డ్ బయాస్ కండిషన్ చేయటం వల్ల ఈ డిప్లీషన్ రీజన్ అనేది మనకు థిన్గా ఉంటుంది అనమాట. దిస్ డిప్లీషన్ రీజన్ ఈస్ వెరీ స్మాల్, whereas this depletion region is very large. Why? Because it is this collector side is reverse biased. Okay. That is the meaning of small. Depletion region is small means it is forward biased. Depletion region large means it is reverse biased. Here, the biasing of the transistor is this one. I am taking one layered type of PNP type of transistor as well as NPN type of transistor is considered here. That is by providing some voltage supply across this emitter side as well as collector side, some voltage is provided. That emitter side is forward biased means P is connected to positive and N is connected to negative, and collector side is should be biased in the reverse fashion, that is in the reverse bias condition. Then N is connected to positive and P is connected to negative. Then it is in then input side is in forward bias condition and output side is in reverse bias condition. Therefore, our transistor is in which mode? Which mode it is operating? Then our transistor is operating in active region or active mode. Similarly, here also by using that same phenomena, we are connecting this n-type, p-type and n-type materials are connected to the this voltage supply here. Okay. Here in this PNP type of transistor, majority carriers are holes and minority carriers are electrons, whereas in NPN type of transistor, majority carriers are electrons and minority carriers are holes here. Main current generation is taking place because of in NPN type of transistor, main current flow of current is mainly because of electrons, whereas in PNP type of transistor, the flow of current mainly because of holes. That is the thing here. But we are going to consider both the charge carrier current here. Therefore, we are treating this transistor as a bipolar here. Okay. And these are the different operating modes of transistor. This is emitter base junction, collector base junction, and region of operation. If emitter base junction as well as collector base junction, this emitter base junction as well as collector base junction is considered because we are applying some voltage supply across emitter side as well as collector side. Therefore, by applying those voltages, if I am applying some positive voltage to the emitter side, then I can call that biasing condition as forward bias condition. If I am applying some negative voltage to the collector side, I can treat that biasing condition as reverse bias. That is the meaning here. Forward bias condition and reverse bias condition. Therefore, the region of operation is known as, we can treat that region of operation is active region here. And similarly, this emitter base junction and collector base junctions both are operated in forward bias condition. I can treat that region of operation is saturation here. If both the regions are operated in reverse bias, I can treat that region of operation is cutoff region. This is emitter base junction is, I am reversing these two terminals here. I am reversing the biasing condition of biasing state of these two, emitter base junction and collector base junction reversing. Therefore, emitter base junction is reverse biased and collector base junction is forward biased. I can treat that region is inverted active region. Inverted active region. These are the different operating modes of the transistor. Thereafter, after knowing those different modes, operation of PNP transistor and NPN transistor. In this operation of PNP transistor and NPN transistor, I am considering the flow of holes is taking place from this is the positive terminal of battery, and it is get transmitted. The holes are transmitting in this side, emitter to base via the base, and finally to the collector. 100% of the 100% of the charge carriers is transmitting from emitter side to the collector side, and in between 2% is absorbed by the base. 2% is absorbed by this base due to the recombination, and 98% of these charge carriers are are, are transmitted to the collector side. Therefore, the total amount of current, the flow of charge carriers, that is due to the flow of charge carriers, that is holes into the collector, I am getting some current here. That current is, let it be some 98%, like that I am going to obtain. Total current is given by IE is equal to IB plus IC. I can treat this current as IB, and I can treat this current as IC. Therefore, emitter current is given by emitter current IE is equal to IB plus IC. That is the meaning here. IB plus IC. That is the diagram. Operation of PNP transistor అంటే ఈ డయాగ్రామ్ వేసి మీరు అంతా ఎక్స్ప్లెయిన్ చేయాలన్న. ఓకే. అండ్ Thereafter, the same principle, the same layered diagram, layered diagram is considered in NPN type of transistor also is considered. It is applied with some biasing condition of biasing condition here. That is, N is connected to negative and P is connected to positive. That means emitter base junction is forward biased and collector base junction is reverse biased. P is connected to negative and N is connected to positive. And the the flow of current is taking place in this direction. Actually, these electrons are repelled by this negative terminal of battery, and these electrons are transmitting from emitter to collector only. But for our convenience, we are taking the conventional direction here. This is the that emitter current is transmitted to base as well as collector. In that, this is the direction of IE is in this direction. It will flow into the base terminal as well as into the collector terminal like that. Actual flow is from emitter to base and then to the collector. Okay. Outward flow of the current in this circuit is emitter current. Emitter current that is given, that is explained in the yesterday's class. Okay. This is about the PNP type of transistor and NPN type of transistor. The current flow we have considered there. Hmm. In today's class, we are going to see the current components in a transistor. Okay, please focus upon this topic, current components in a transistor. Here, this is I am considering PNP type of transistor only. Here, I am going to consider PNP type of transistor. If you want to explore some other topic like NPN, also you can go through different textbooks. You can come across the current components in NPN transistor also. Okay. I will I will base that material in some other in some other notes like that. Okay, don't worry. This is for time being. We will see the what are the current components of PNP type of transistor. Let it be. I am considering this is the P type. I am drawing this one again. Redrawing this one. This is P type. P type semiconductor, and in between N-type semiconductor and P-type semiconductor. This P-type is connected to positive terminal of battery, and N-type is connected to negative terminal of battery, and N-type is connected to negative terminal of battery. Then I can call this condition is forward bias condition. I can call this biasing condition is forward bias. Similarly, P is connected to negative, and N is connected to positive. I can treat this condition as reverse bias condition. I can treat this biasing condition as reverse biased. Okay. This is first one is forward biased, and it is in and the output circuit side is in reverse bias condition. And thereafter, I am going to obtain by proper biasing of this voltage supply. Proper biasing from is done by using this voltage supplies. The flow of current will take place here in this p-type semiconductor material. That means from emitter side the majority carriers are there. The majority carriers are holes, and those holes are repelled by this positive terminal of battery. That means those holes are transmitted in this direction. Those holes are transmitted from emitter to the collector terminal in this way. In this way, from left to right, those charge carriers are transmitted. Let us assume that in we have up till now we have discussed about exterior part of the circuit diagram. We are going into the circuit diagram, into the layered diagram. We are going into the layered diagram. Please observe, this is the emitter current. Across emitter side, and some flow of current is taking place. That current is emitter current. And across collector side, some flow of current is taking place. That flow of current is mainly because of collector side. I am getting some flow of current. That current is IC. And across base terminal side, I am getting some small amount of flow of current. That current is IB. Emitter side emo కరెంట్ ఫ్లో అవుతుంది. ఆ కరెంట్‌ని ఎమిటర్ కరెంట్ అనుకుంటాను. బేస్ టెర్మినల్ దగ్గర సమ్ కరెంట్ ఫ్లో అవుతుంది. ఆ కరెంట్‌ని బేస్ కరెంట్ అంటాను. కలెక్టర్ దగ్గర ఒక టైప్ ఆఫ్ కరెంట్ ఫ్లో అవుతుంది. ఆ కరెంట్‌ని కలెక్టర్ కరెంట్ అంటాను అన్నమాట. Here, this emitter current, the flow of current is taking place in this p-type layer. Assume that it has in the p-type layer some flow of current is taking place, that is IPE. That I'm taking that, I'm considering that current as IPE. IPE. P means, what is P means? What is in previous classes? What is the notation given for P? P means holes. P means holes, whereas E means, that is emitter. That is emitter. Suffix I, suffix PE means, that is mainly because of P means holes, hole current in the emitter side. On the emitter side, that is given by IPE. Similarly, this P-type semiconductor material consists of minority carriers also. Minority carriers also. That current, I am going to treat that current as INE. INE, it consists of some minority charge carriers. That current is given by INE. That current is given by INE, where N means electrons, E means emitter. On the emitter side, the whole current, majority current, I am considering the majority current, whole current, majority, as well as whole current, majority, as well as and minority current flow. Both the current flows I am considering here, that is IPE as well as INE. INE. That is the meaning of this diagram. That whole current is transmitting in this direction, and let it be that electron current is also transmitting in the direction INE. By considering both the currents, I am drawing the circuit like this. That is IPE and INE. Okay. Next, in between and thereafter, this current, the same amount of current is transmitted to the collector side. To the collector side. Therefore, I am getting that current here, whole current as IPC. I am treating across the collector side. I am treating that current as IPC. IPC. P means holes. P means holes, and C means collector side. The whole current across collector side. That is the meaning. Whole current across collector side, that is IPC. Similarly, and due to the small amount of minority carriers flow, due to the minority charge carriers, small amount of current flow is taking place here. That small amount of current flow, I can treat that current flow as reverse saturation current here. I am going to treat that current flow as reverse saturation current. Reverse saturation current flow. That is given by I see not here. I see not. It is that current is flowing across the collector side, but it is flowing in the reverse way. In the reverse way that is flowing, I can treat that current as reverse saturation current. Inbuiltly, inbuiltly, this reverse saturation current consists of both the both the this reverse saturation current consists of both the electrons and holes. That means this P region consists of some minority carriers. This N region consists of some minority carriers. The combination of these holes as well as the combination of these electrons is also taking place. In P-type semiconductor material, minority carriers are electrons, whereas in N-type semiconductor material, the minority carriers are holes. Holes like that. It is this reverse saturation current is flowing mainly because of these both minority carriers. I am going to consider this electron minority current as well as whole minority current in the reverse direction. In the reverse direction, I am going to obtain here, that is treated as INC naught, INC naught, and IPC naught, like that. I am going to consider. Okay, that is about the reverse saturation current here. That means here the same current. This is regarding minority carrier current flow. I am getting the reverse saturation current here, and as well as here I am applying 100% of the emitter current. Emitter current 100%. Just wait. I am obtaining 100% of the emitter current. I am giving out some 100% of emitter current, and 2% is transmitted to this side, 2% to the base side, and the remaining 98% is transmitted to the collector side. 98% of the current is transmitted to collector side. Okay, like that. In view of that, I can tell this as the recombination of the current is taking place from IPE, this IPE, as well as inbuiltly this N-type semiconductor material consists of some electrons are there. The recombination, that those recombination will take place. The combination of electrons and holes will take place, and that recombination, due to that recombination, some small amount of current is flowing across the base. That small amount of current flow I am considering here, that small amount of current flow is IB. IB. That is mainly because of IPE, this current, IPE minus IPC. ఈ రెండింటి మధ్యలో ఉన్న డిఫరెన్సే నేను ఈ రీకాంబినేషన్ కరెంట్గా తీసుకుంటాను అనమాట. ఇది ఐపీఈ మైనస్ ఐపీసి. ఐపీఈ మైనస్ ఐపీసి ఐఎమ్ గోయింగ్ టు కన్సిడర్ that current is given by recombination current, IPE minus IPC. Just a minute, I will continue. Some noise is coming. Just a minute, for 2 minutes. Just wait. Okay. These are the various current components that flow across the forward biased emitter junction. This is forward biased emitter junction and reverse biased collector junction in the PNP type of transistor. The emitter current consists of two parts here. The emitter current consists of two parts, that is whole current. Whole current is given by IPE, constituted by holes across from the emitter to the base. It is those whole current is transmitted from emitter side to the base side. From emitter side to the base side, that current is flowing mainly because of holes. Similarly, the electron current is also flowing in the P-type semiconductor material. That current is given by electron current is given by INE. INE constituted by electrons, that is from base to the emitter side. Base to the emitter side, that flow of current is taking place. That flow of current is taking place here, that is from base to the emitter side. Electron current is taking place, that is INE. Whole current is from emitter to base side, and the electron current is from base to emitter side. There is a possibility of transmitting of electrons into the P region, and there is a possibility is taking place from P region to the N region. Like that, the transmission of both the charge carriers will take place from one layer to the another layer. Therefore, total emitter current is given by IPE. This is the combination of these two currents, IPE plus INE. This is total emitter current is given by IPE is equal to IPE, IE is equal to IPE plus INE. IPE is mainly because of majority charge carriers. INE is mainly because of minority charge carriers. IPE అనేదేమో మెజారిటీ ఛార్జ్ క్యారియర్స్ వల్ల వస్తుంది, INE అనేదేమో మైనారిటీ ఛార్జ్ క్యారియర్స్ వల్ల వస్తుంది అనమాట. That is the total current of emitter is given by IPE plus INE. Let IPC is the whole current at junction దగ్గర IPC అనేది మనం ఒక హోల్ కరెంట్గా తీసుకుంటాం అనమాట. హోల్ కరెంట్ at the junction. The difference, this is the junction. Across the junction, IPC is the whole current at junction JC. The difference between IPE minus IPC is the recombination current. I can take some current flow here. That current flow, I am going to take the current flow, main current flow. This is the main current flow, that is given by IPE minus IPC, and the resultant current, I am going to obtain the resultant current is IPE minus IPC. That means 100% minus 98%. Some small amount of current is flowing, that is 2% of current is flowing due to the recombination of electrons and holes is taking place across the junction, across the base. That current flow, I am treating that current flow as IP. The difference is IPE minus IPC. IPE minus IPC is the recombination current IB. I am going to treat that current as IB is equal to IPE minus IPC. IPC. That recombination current is given by IPE minus IPC. That current is leaving the base. That current is going to be leaving the base. So I am considering that as I am going to consider ఇప్పుడు ఇప్పుడు కేవీఎల్ వేసాం అనుకున్నాం కేసీ ఇప్పుడు కరెంట్లోకి ఫర్ ఎగ్జాంపుల్ సింప్లీ కిచ్ ఆఫ్స్ వోల్టేజ్లో అండ్ కరెంట్లో ప్రకారం అకార్డింగ్ టు కేసీఎల్ సింపుల్గా తీసుకున్నాము కేసీఎల్ at one node the currents entering the nodes I am going to take it as current entering the node I am going to take it as entering the node leaving the node entering the node I am going to take it as positive and leaving the node I am going to take it as negative like that. Here entering current is IE and leaving currents are both this base current as well as collector current. Therefore IE minus IB minus IC is equal to 0. Therefore IE is equal to IB plus IC. From that KCL I can give this relation between this emitter current, base current as well as collector current like that. Okay. And further if emitter were open circuited ఇప్పుడు ఈ ఎమిటర్ సైడ్ ని ఓపెన్ సర్క్యూట్ చేశానంటే ఓపెన్ సర్క్యూట్ అంటే ఏంటి మీనింగ్ వాట్ ఈస్ ద మీనింగ్ ఆఫ్ ఓపెన్ సర్క్యూటెడ్ హియర్ ఎనీవన్ ప్లీజ్ రెస్పాండ్ వాట్ ఈస్ ద మీనింగ్ ఆఫ్ ఓపెన్ సర్క్యూటెడ్ హియర్ what is the meaning of open circuited please tell me. I am not going to apply any sort of voltage here therefore IE will become ఇక్కడ వోల్టేజ్ అప్లై చేయలేదమ్మా అప్పుడు ఎమిటర్ కరెంట్ ఏమైంది
Zero.
Then emitter current is 0, right? Then emitter current is 0. That is the meaning given here. If emitter were open circuited, then IE is equal to 0. That is IPC would be 0. ఇప్పుడు ఈ ఎమిటర్ కరెంట్ లో నుంచేగా ఈ ఐపీసీ వచ్చేది మనకు రిజల్టెంట్ ఇది ఐపీఈ ఈస్ రిజల్టెంట్ ఆఫ్ ఐపీసీ. దట్ మీన్స్ దిస్ ఈస్ ఐపీసీ డిపెండ్స్ అపాన్ దిస్ ఐపీఈ ఓన్లీ. ఇక్కడ వచ్చే మన కలెక్టర్ దగ్గర వచ్చే కరెంటు దేని మీద డిపెండ్ అవుతున్నట్టు ఎమిటర్ మీద డిపెండ్ అవుతున్నట్టు అనమాట. ఇప్పుడు ఎమిటర్ కరెంటే 0 అయినప్పుడు అప్పుడు మన కలెక్టర్ కరెంట్ వచ్చిందా ఏమన్నా కరెంట్ ఉంటుందా ఉండదు కదా. అది ఓపెన్ సర్క్యూట్ చేసినప్పుడు ఆటోమేటికలీ దట్ ఐపీసీ ఈస్ గోయింగ్ టు బి 0. దట్ ఈస్ ద మీనింగ్ ఆఫ్ దిస్ వన్. The emitter were open circuited, then IE is equal to 0, that is IPC would be 0. Under this condition, the base and collectors together acts as the base and collector. Under this condition, this is 0 and this is I am talking about output circuit side, that is across collector side. Collector and base terminals are going to be in the reverse bias condition, acts as a reverse diode, and the collector current is given by IC is equal to IC naught. That collector current, this reverse saturation current, ఇది 0 అయినప్పుడు ఇప్పుడు ఇన్పుట్ సర్క్యూట్ సైడ్ ఎమిటర్ సర్క్యూట్ సైడ్ is open circuited, then the flow of current IPC is equal to 0. Then small amount of current is flowing, though I am not at all applying any sort of voltage to the emitter side. I am getting small amount of minority carrier current flow across the P. It is just like a diffusion of charge carriers is taking place from P side to the N side and N side to the P side. That small amount of current flow is taking place mainly because of minority charge carriers that is given by here IC not here. That current I am going to treat that current as reverse saturation current. I am treating that current as reverse saturation current here. That is given here. That is, and the collector current IC is equal to, ఇప్పుడు మనకి IC నాట్ లేదా IPC లేదమ్మా, IPC అనేది కూడా 0 అయింది. అప్పుడేమవుద్ది, అండ్ ఓన్లీ రివర్స్ సాచురేషన్ కరెంట్స్ రిమైన్స్ దేర్, దట్ ఈస్ IC నాట్. Reverse saturation current has two parts. Those two parts are INC naught caused by electrons moving across the collector junction JC from P region to the N region. INC naught ఎట్లా వస్తుంది, ఫ్రమ్ P region నుంచి N region కి వెళ్ళేటప్పుడు I am going to acquire this INC naught. from P region to the from P region to the N region, I am going to acquire some flow of current. I am going to acquire that is given by that current is IN C naught. P region నుంచి N region కి వెళ్ళేటప్పుడు from P region to the N region some flow of current is taking place. That current I am going to treat that current as P region నుంచి ఏ కరెంట్ వెళ్తుంది, ఏ కరెంట్ వెళ్ళి చెప్పండి P region నుంచి N region కి. పీ రీజన్లో మైనారిటీ క్యారియర్స్ ఉన్నాయి కదమ్మా. పీ రీజన్లో మైనారిటీ క్యారియర్స్ ఏంటి, హోల్స్, ఎలక్ట్రాన్స్. పీ రీజన్లో మైనారిటీ క్యారియర్స్ ఎలక్ట్రాన్స్ దట్ ఈస్ ట్రాన్స్మిటెడ్ టు ది ఎన్ రీజన్. ఎందుకని దోస్ ఎలక్ట్రాన్స్ ఆర్ గెట్ ట్రాన్స్మిటెడ్ టు ది ఎన్ టైప్ సెమీకండక్టర్ మెటీరియల్ ఓన్లీ. ఐ కెన్ ట్రీట్ దట్ కరెంట్ ఫ్లో యాజ్ ఐఎన్ సి నాట్. రివర్స్ సాచురేషన్ కరెంటు అది ఎన్ టైప్ సెమీకండక్టర్ మెటీరియల్ వైపే వెళ్తుంది కాబట్టి ఐ కెన్ ట్రీట్ దట్ కరెంట్ యాజ్ ఐఎన్ సి నాట్. సిమిలర్లీ ద హోల్స్ విచ్ ఆర్ ప్రెజెంట్ ఇన్ ఎన్ రీజన్, హోల్స్ ఇక్కడ ఎన్ రీజన్లో ఏంటి మైనారిటీ క్యారియర్స్, హోల్స్ అనమాట. ఆ హోల్స్ ఏమవుతున్నాయి, పీ రీజన్ వైపు ట్రాన్స్మిట్ అవుతున్నాయి. అప్పుడు ఆ కరెంట్ ఏమంటాను నేను, ఐపీ సి నాట్ అంటాను అనమాట. ఇప్పుడు ఇక్కడ రివర్స్ సాచురేషన్ జరుగుతుందా, ఇక్కడ రివర్స్గా ఎన్ రీజన్ నుంచి పీ రీజన్కి సమ్ ఫ్లో ఆఫ్ కరెంట్ ఈస్ టేకింగ్ ప్లేస్, దట్ ఈస్ హోల్స్. Let it be minority carrier current flow is from N region to the P region, that is holes is taking place. I can treat that current flow as IPC naught. Similarly, the electrons are transmitted from P region to the N region, that is I can treat that current as IN C naught. మైనారిటీ క్యారియర్స్ మాత్రమే తీసుకుంటే పీ నుంచి మైనారిటీ క్యారియర్స్ ఏం ఫ్లో అవుతున్నాయి, బేస్ ఇక్కడ ఎన్ టైప్ సెమీ కండక్టర్ మెటీరియల్ కదా, ఆ బేస్లోకి ఏ ఏ ఏ ఫ్లో ఆఫ్ కరెంట్ ట్రాన్స్మిట్ అవుతుందంటే మైనారిటీ క్యారియర్ కరెంట్ ఫ్లో. అది దట్ ఈస్ ఫ్రమ్ P side to the N side is get transmitted, that is that current. I am treating that current as INC naught. Similarly, some base current to the in this N type semiconductor material, minority carriers are holes. That whole current is taking place from N side to the P side. I am treating that current as IPC naught. IPC naught. Suffix N ఉంటే ఏమంటున్నాం, ఎలక్ట్రాన్ కరెంట్, మైనారిటీ ఎలక్ట్రాన్ కరెంట్, C0 అని ఇచ్చాం అనమాట. C0 అని ఇస్తే దట్ ఈస్ మైనారిటీ కరెంట్ డ్యూ టు ది రివర్స్ సాచురేషన్ వల్ల మనకి ఆ కరెంట్ ఫ్లో జరుగుతుంది. ఆ కరెంట్ ఫ్లోని విత్ రెస్పెక్ట్ టు ఎలక్ట్రాన్స్ అయితే సఫిక్స్ ఎన్ అని రాస్తాం, విత్ రెస్పెక్ట్ టు హోల్స్ అయితే సఫిక్స్ పి అని రాస్తాం అనమాట. INC naught caused by electrons moving across the junction JC from P region to the N region. IPC naught caused by holes moving across the junction JC only. రెండు జంక్షన్ JC దగ్గరే జరుగుతుంది. రెండు కూడా ఆ టూ ఫ్లో ఆఫ్ ఎలక్ట్రాన్స్ మైనారిటీ క్యారియర్స్ ఫ్లో ఎక్కడ జరుగుతుంది, జంక్షన్ JC దగ్గరే. ఈ జంక్షన్ JC only. Okay, this point is very important for analyzing this circuit. Across the junction JC only the movement of minority carriers is taking place. Okay, and this is the IPC naught caused by IPC naught caused by holes moving across collector junction JC from N region to the P region. Therefore, this reverse saturation current IC naught is given by INC naught, this current INC naught, as well as this current, this electron current as well as minority hole current. I am going to consider, because it is operated in reverse bias condition, I can treat that current flow that it has reverse saturation current here. IC naught is equal to INC naught plus IPC naught. Therefore, that reverse saturation current is given by IC naught is equal to INC naught plus IPC naught. In general, normally the collector current is given by IPC is equal to that collector current IC is equal to IPC plus, I can treat that current IPC is mainly because of majority carriers, IC naught is mainly because of minority carriers. Therefore I can write that entire equation as IC is equal to IPC plus IC naught. ఇప్పుడు మనకు వచ్చే కలెక్టర్ కరెంట్ ఏముందమ్మా టోటల్గా, ఈ IPC as well as this reverse recombination current, that is recombination current is IC naught. లేకపోతే సింపుల్గా చెప్పాలంటే కలెక్టర్ సైడ్ ఏమేమి కరెంట్స్ ఉన్నాయి మనకి, ఇక్కడ కలెక్టర్ సైడ్ IPC ప్లస్ IC naught, ఇక్కడ ఎమిటర్ సైడ్ ఏమేమి కరెంట్స్ ఉన్నాయి IPE ప్లస్ INE. Like that you can easily remember these 2 points. Emitter side ఉన్న total currents ఏంటి IPE plus INE, whereas ఇక్కడ collector side ఉన్న total currents ఏంటి IPC plus IC naught. Like that you can remember, that is IC is equal to IPC plus IC naught. This IC naught again consists of two parts, that is INC naught and IPC naught. That is this is mainly, this is IPC is majority carriers and IC naught is only because of minority carriers. Here IC నాట్, దట్ ఈస్ ఐసీ నాట్ అనేది మనకి పిఎన్పి టైప్ ఆఫ్ ట్రాన్సిస్టర్లో ఈ రివర్స్ సాచురేషన్ కరెంట్ అన్నది నెగిటివ్గా ఉంటుందన్నమాట. రివర్స్ సాచురేషన్ కరెంట్ ఈస్ నెగిటివ్ ఇన్ పిఎన్పి టైప్ ఆఫ్ ట్రాన్సిస్టర్, వెరాస్ ఐసీ నాట్ ఈజ్ పాజిటివ్ ఫర్ ఎన్పిఎన్ టైప్ ఆఫ్ ట్రాన్సిస్టర్. మనకి ఆ లేడ్ డయాగ్రామ్లో కొన్ని టెక్స్ట్ బుక్స్లో మనకు క్లియర్గా ఉంటుంది అనమాట. ఈ ఐసీ నాట్ అన్నది మనకి ఇక్కడ ఏంటి నెగిటివ్ అనమాట. రివర్స్ సాచురేషన్ కరెంట్ నెగిటివ్గా తీసుకుంటాం. అదే ఎన్పిఎన్ ట్రాన్సిస్టర్లో ఇదే రివర్స్ సాచురేషన్ కరెంట్ పాజిటివ్ అవుతుంది అనమాట. పిఎన్పిలో రివర్స్ సాచురేషన్ కరెంట్ ఏంటి, రివర్స్ సాచురేషన్ కరెంట్ towards n it is flowing, therefore I am going to take that current flow as negative. I am going to take that current as negative, whereas in npn type of transistor I am going to consider that IC naught as positive. Okay, that is the basic difference between PNP and NPN type of circuits. The basic difference, IC naught is going to be varied. IC naught is going to be varied. That is going to be negative for PNP type of transistor, and that is positive for NPN type of transistor. Thus, for a PNP transistor, thus for a PNP transistor, emitter current is given by the relation. Emitter current is given by IE is equal to IB plus IC. IB plus IC. From this KCL, from the KCL equation, I can give that it as. ఇప్పుడు యాక్చువల్గా ఇది ఎట్లాగా ఫస్ట్ ఎట్లా ఉంటుందంటే, ఫ్రమ్ కేసీఎల్ ఐఈ మైనస్ ఐబి మైనస్ it is the summation of all the currents across the node. అంతే కదా, summation of all the currents across the node. Those currents which are entering are treated as positive and leaving currents are treated as negative. Like that, IE minus IB minus IC is equal to 0. From that equation, IE is given by IE is equal to IB plus IC. Like that, I can write it as emitter current as IE is equal to IB plus IC. That is the final equation we are going to write here. That is emitter current is both the combination of base current as well as collector current. Okay, this is very very important. కరెంట్ కాంపోనెంట్స్ అనే ట్రాన్సిస్టర్ జనరలైజ్డ్గా అడుగుతారు. జనరలైజ్డ్గా మీకు ఎగ్జామినేషన్లో దాన్ని పిఎన్పి టైప్ కూడా అడగచ్చు, ఎన్పిఎన్ టైప్ అయినా అడగచ్చు అనమాట. ఈ డయాగ్రామ్ చాలా ఇంపార్టెంట్, ప్రాక్టీస్ చేయండి. మీరు ఇది అసైన్మెంట్ అనమాట. ఇది మీరు పిఎన్పి టైప్ ఆఫ్ ట్రాన్సిస్టర్ డ్రా చేయండి, ఎన్పిఎన్ టైప్ ఆఫ్ ట్రాన్సిస్టర్ కూడా డ్రా చేసి చూసుకోండి. రెండింటికి డ్రా చేయండి. అక్కడున్న కరెంట్ ఫ్లోస్ ఎట్లా ఉన్నాయి ఏంటనేది నాకు చెప్పాలి. సరేనా? అది మీరు ఒకసారి బ్రౌజ్ చేయండి, నెట్ బ్రౌజ్ చేయండి, లేకపోతే డిఫరెంట్ టెక్స్ట్ బుక్స్ చూడండి. దాన్ని బట్టి మీరు రెండు కాంపోనెంట్స్ వేయండి. టూ కరెంట్ కాంపోనెంట్స్ ప్రెసెంట్ ఇన్ బోత్ పిఎన్పి టైప్ ఆఫ్ ట్రాన్సిస్టర్ యాజ్ వెల్ యాజ్ ఎన్పిఎన్ టైప్ ఆఫ్ ట్రాన్సిస్టర్. రెండు చూసుకోవాలి. ఓకేనా? ఆ రెండు చూసుకొని డ్రా చేస్తే మీరు ఏది అడిగితే అది మీరు ఎగ్జామ్లో ఈజీగా రాయగలరు. అండ్ why silicon is most widely used, these are the following reasons. A silicon crystal has fewer free electrons than germanium crystal at room temperature. This shows that silicon will have much smaller collector cutoff current. Silicon ఏంటంటే much smaller collector cutoff current, that is ICB0, than germanium. సిలికాన్ ఏంటంటే మచ్ స్మాలర్ కలెక్టర్ కరెంటు చాలా తక్కువగా ఉంటుంది అన్నమాట ICB0 అనేది. ఇదేంటంటే మనం ఫర్దర్గా చూస్తాం వాట్ ఈస్ ICB0, యూ విల్ సీ లేటర్ ఆన్, డోంట్ వరీ. జస్ట్ ఫర్ టైం బీయింగ్ నో ది సిలికాన్, వాట్ ఈస్ ద అడ్వాంటేజ్ ఆఫ్ సిలికాన్ వెన్ కంపేర్ టు ది జెర్మేనియం అనేది గుర్తుపెట్టుకోండి. దట్ ఈస్ few freer electrons. The silicon crystal has few freer electrons than germanium crystal at room temperature. This shows that silicon will have much smaller collector cutoff current, that is ICB0, than germanium. Small variation of ICB0 will take place with respect to temperature. That means stable. Silicon is more stable than compared to germanium. And by varying this temperature, the variation in the temperature, the operating range of the silicon is in between 120 degrees. The operating range is 150 degrees centigrade whereas the operating range for germanium is 70 degrees centigrade. Beyond the 70 degrees centigrade, the variation in the semiconductor may take place for germanium, whereas beyond 150 degrees means it is a very huge amount of temperature. Beyond that point only the variation in the silicon may take place, the variations in the silicon may take place. and and ICB not approximately doubles for every 8 degrees to 10-degree rise in temperature. For every 10-degree rise in temperature, ICB not get doubles here. What is this ICB not means? Just like a reverse saturation current, like that we will come across this term in the forthcoming discussions. Okay, germanium, while it doubles for every 12 degrees rise in temperature, like that it is going to be varied. That means silicon crystal is more stable with respect to germanium. First one is silicon is more stable with respect to temperature. Next point is this silicon is a collector cutoff current. Collector cutoff current is very low, very small value when compared to germanium, and the variation that is change in the temperature level, it is maximum variation with small variation in the temperature. There is a stability of the transistor is very less. Stability of germanium transistor is very less when compared to the silicon stability paranga. Stability అనేది దేని మీద డిపెండ్ అయి ఉంది? సిలికాన్ మీద డిపెండ్ అయి ఉంటుంది అన్నమాట. సారీ, స్టెబిలిటీ అనేది టెంపరేచర్ మీద డిపెండ్ అయి ఉంటుంది. సారీ, అదే కదా, ఆ స్టెబిలిటీ అనేది విత్ రెస్పెక్ట్ టు టెంపరేచర్తో తీసుకుంటే, ఫర్ ఎగ్జాంపుల్ ద టెంపరేచర్ ఈజ్ 70 డిగ్రీ సెంటిగ్రేడ్ ఫర్ జర్మేనియం, 150 డిగ్రీ సెంటిగ్రేడ్ ఫర్ సిలికాన్. అట్లాగా ఆ టెంపరేచర్ మీద డిపెండ్ చేసుకొని ఆ వేరియేషన్ పర్టికులర్ పారామీటర్స్ ఇన్సైడ్ ది సిలికాన్ వేరియేషన్స్ ఆర్ గోయింగ్ టు టేక్స్ ప్లేస్ విత్ రెస్పెక్ట్ టు ది వేరియేషన్ ఇన్ ది టెంపరేచర్. ఆ వేరియేషన్స్ రావటం వల్ల ఏంటంటే మనం స్టెబిలిటీని చెప్పొచ్చు అనమాట. సిలికాన్ ఈజ్ మోర్ స్టేబుల్ దాన్ జర్మేనియం అని చెప్తాం. అట్లానే that is a collector cutoff current kuda, that is ICB naught is very much less for silicon when compared to the germanium. And for every 10 degree rise in temperature, those parameters that ICB naught is going to be varied like that. Okay, that is this ICB naught doubles for every 10-degree rise in temperature for germanium when compared to silicon. ఓకే, ఇది 8 డిగ్రీ సెంటిగ్రేడ్ దగ్గరే వేరియేషన్ మొదలు పెడితే మనకి 12 డిగ్రీ సెంటిగ్రేడ్ దగ్గర సిలికాన్ యూస్ చేసేటప్పుడు 12 డిగ్రీ సెంటిగ్రేడ్ దగ్గర వేరియేషన్ వస్తుంది అనమాట. దట్ ఈస్ ద మీనింగ్ హియర్. ఓకే, దట్స్ వై సిలికాన్ ఈస్ మోస్ట్ వైడ్లీ యూస్డ్ ఫర్ మ్యానుఫ్యాక్చరింగ్ ఆఫ్ ట్రాన్సిస్టర్స్ ఆల్సో. ఓకే, and this is the next topic is transistors are operated in three types of configurations. Those three types of configurations is emitter base junction, emitter, sorry, just a minute. Configurations, we are considering three configurations. Those configurations are common base, common emitter, common collector. We will see this in each and every class. We are going to give the proper explanation of common base, common emitter, and common collector. What is this terminal common? Meaning common, we will see. We will see. Common base means base terminal is common between input circuit side as well as output circuit side, whereas common emitter means emitter terminal is common between input circuit and output circuit side. And the common collector means common terminal is collector. Then the let it be, I will draw this one: emitter base collector. This emitter terminal, let it be, it is grounded. Then this base terminal is common between emitter and collector. I can treat that configuration as common base configuration. I can treat that configuration as common base configuration. And common emitter configuration means is common between emitter is common between this base and collector. I can treat that configuration as common emitter configuration. Similarly, common collector configuration means this collector terminal is common between emitter and base. I can treat this. I can treat this. These two terminals are. These two terminals are. This collector terminal is common between emitter and base. emitter and base, I can treat that configuration as common collector configuration. Common collector configuration, simply the term common is used to denote the transistor lead which is common to the input and output circuits. ఆ టెర్మినల్ కామన్గా ఇన్పుట్ సర్క్యూట్ సైడ్ అవుట్పుట్ సర్క్యూట్ సైడ్ ఉంటుంది కాబట్టి ఐ కెన్ ట్రీట్ దట్ కాన్ఫిగరేషన్ as కామన్ with respect to base, common with respect to emitter, common with respect to collector. Like that, I am going to treat here the terminal is common between input circuit and output circuit side. So the transistor has three terminals, and in that one terminal is common to the both the input and output terminals. Therefore, common terminal is generally grounded. That common terminal is generally it is going to be grounded. Depends upon that grounding condition. I can treat that configuration is whether it is a base type, emitter type, or collector type. I am going to categorize like that. We are going to see the different configurations. Those three configurations are common base. We can simply we can call that it as CB configuration, and a common emitter configuration, simply we can call that it as common CE configuration or common emitter configuration. And third one is common collector configuration. Simply we can treat that it as CC. Okay. Okay, this is about regarding the configuration. We will discuss this topic more elaborately in the subsequent classes. Okay, just a minute.